Hello everyone, and welcome to the 32nd episode of TechLifeSkills with Tanmay. My name is Tanmay Bakshi, and on this show every week, I go live with the goal of making advanced technology concepts more accessible to everybody. And to do this, we hear from a diverse range of guests, all the way from leaders with decades of experience to students who are just starting their journeys. And now, as I mentioned, as part of this goal, I really do try to bring on a diverse range of guests. And this is not only to cover a really wide range of technologies, but also to cover a lot of different perspectives. And as I'm sure you know, one of my favorite technologies is AI, or machine learning. And we've covered that quite a bit on the show, but a lot of it has been from this scientific and sort of research angle. And so now, I want to figure out more about the world of actually translating that research into production use cases where people will actually be using the technology. Now, there's all sorts of things we need to do here, all the way from making sure algorithms themselves are robust to making sure they're not biased and making sure people actually understand the ideology of the technology. This is all absolutely critical. And that is why I'm so excited to introduce today's special guest, Bret Greenstein, the Senior Vice President and Global Head of AI and Analytics at Cognizant. Now, Bret has decades of experience working with emerging technologies like IoT, AI, machine learning across companies like IBM and Cognizant, just to name a few. And so now, without any further ado, let's welcome Bret to the show. Hi, Bret. How are you?
Doing great. Thank you so much, Tanmay.
Thank you for agreeing to be on the show. It's an honor to have you on. And, actually to start off with, I would love to know a little bit more about you. How did you get to doing what you're doing today, and what sort of led up to this point?
To get to work on AI, especially in 2020, a year where clearly the need for the technology and the possibilities are just endless, a whole career has to get you here.
Mm-hmm.
And I don't think anyone could plan a career that takes you to this point. But my passions early on, started from science fiction. They started from, movies and television and things that really inspired what AI might be able to do one day.
Mm-hmm.
But back then, it really was science fiction.
Mm-hmm.
And over the years, I continued to work on technologies that were close to this. All kinds of work around fuzzy logic and early machine learning systems. And throughout all of that, it was clear the potential was high.
Mm-hmm.
But it was really only in the last decade that the technology took off with the growth of deep learning and the ability to do really practical things with AI at costs that are reasonable. Almost anybody can do.
Mm-hmm. Okay, that's really interesting, and sort of what you touched upon towards the end there is something that I'm really passionate about, because I feel like with modern AI and machine learning, one of the sort of driving factors as to how it's been growing this fast is the fact that pretty much anybody can access this technology, right? Like tomorrow, if I had some amazing idea for an AI machine learning system that could, save lives in healthcare, in theory, I could just go up to, IBM Cloud or AWS or Google Cloud, and I could just spin up a bunch of virtual machines with GPUs, and suddenly I'm experimenting with machine learning, right? So the fact that this, other technologies like cloud, for example, have actually made the compute power more accessible has been one of those driving factors as to, making machine learning more accessible. And what you mentioned around, the inspiration from science fiction, I feel like that's definitely very interesting. But go ahead, were you saying something?
Well, it's just that when computers first emerged, they were the things that only governments and banks could own,
Mm-hmm.
and then they became based on commodity parts, and anybody in their garage could make something, and Apple and everything else came from that.
Mm-hmm.
And now it's the same idea that the services that people need for AI are available in the cloud for
Mm-hmm.
pennies. Anybody
Absolutely.
can do it. What it requires, though, is people who understand data, the value of data, and what the potential of data is.
Mm-hmm.
There was a startup I worked with in Toronto. It was just four guys working in their parents' loft. And they decided they could determine if people were smoking by looking at gestures and identifying gesture patterns. And they would help people quit smoking by recognizing the behaviors that were so habitual we don't even notice them, and help eliminate them. So identify when you're doing certain things, help you realize it, and then take away those behaviors, break the habits, get out of smoking. And it was a simple algorithm that looked at motion, used some very basic machine learning and data off of Fitbit-like devices. It was really cool, though. Anyone
Wow.
could do this.
That is incredible. You know what I absolutely love about the example you just gave here is I think it perfectly highlights, as you mentioned, just how relevant data is. I feel like AI machine learning is actually less about the machine learning and more about the data that you feed into these algorithms, right? It's all about being able to find patterns in data. And if you think about it, we as humans, we're pretty predictable creatures. we can have neural networks that can predict the next word in our sentences very accurately now. And that's not necessarily because language is easy, but it's rather because we as humans are really predictable with what we want or what we want to get across as an idea generally, right? Now there are some exceptions, and we'll be talking about that in a moment. But overall, AI sort of works well this way. Now, something that I'm sort of really fascinated by is the fact that as humans, as when we do things like, for example, you mentioned smoking, that has enough of an imprint on our behavior to be detectable in other contexts by machine learning algorithms. But if it weren't for, as you mentioned, the folks that were, sitting there wondering how could we actually use that data, could there be this sort of pattern that we could identify, it wouldn't have been something that we actually, went ahead and sort of implemented as a use case. So it's all about figuring out how to use data.
Yeah, it's about imagining what it might tell you. And I think what most people don't realize is data is happening around us constantly. It's the trail we leave behind and the stuff that we do every day, whether it's in business, in life, at home. And I work with some people who are working on aging in place solutions, so people could stay at home longer. And they were using cameras to identify if somebody's walk looked a little more energetic today. Maybe a limp was going away, or maybe some other indication of whether they were getting better or getting worse. You can also look at the patterns in people's homes and identify, for example, did they start the coffee maker? Did they check the front door for the newspaper? Whatever they might do that is habitual, that starts to look a little different, is an indication something's changed. And I think the really cool part about machine learning is not to look for the stuff that's always the same. It's to look for those changes, as subtle as they may be, and figure out, what do they mean? Are they good? Are they bad? Is there a reason to intervene, or should you just let things play out?
Interesting. Now, what's really fun about that is how exactly that can tie into different use cases, right? You mentioned the sort of, I guess, almost healthcare sort of approach where, we're able to use different cameras and things, do things like pose estimation and try and figure out, should we be, intervening here? Is this person going, sort of progressing well with their medical treatment, things like this. And what's really nice is similar technology can be applied everywhere, right? Machine learning technology is generic enough that the raw tech can be applied to pretty much any domain, and the data can be domain specific, right? Like, for example, in this case, we sort of talked about a use case that will genuinely help, thousands of lives. It'll help people live better lives. But at the end of the day, that same pose estimation algorithm could be used in a gaming use case, right? So that's what's really fun about machine learning, is that raw technology is generic, but the data can be domain specific.
Yeah, and I don't think most people realize just how flexible it is. And if you look at IoT data, for example, data streaming off of devices is generally really boring. But if you step back, it actually tells you a lot about how a machine or a thing is operating. I have a sensor in my refrigerator, and I had my refrigerator was freezing up, and so then the coils wouldn't work and it would overheat. So I put a sensor in, and I was watching the data, and I can see when it's cycling through, and I can see when it's trending and when a problem is coming. You can see a problem coming weeks or months in advance if you're looking for the subtle changes and variations in data. But if you look at it at any moment, it's like, oh, it's cold. That doesn't tell you anything. But machine learning algorithms can see when underlying causes are happening. This is being used in manufacturing, not just my fridge, but in manufacturing and all kinds of other places where really big problems can occur, and you can see them in advance.
Okay, that's really nice, because we've been hearing about this impact of machine learning on manufacturing and similar industries for a long time, and I'd love to know a little bit more about the actual implementations of machine learning in this field. But first, I want to take a bit of a step back, and I actually have another question for you, and that is that I've seen a lot of different misconceptions around AI and how it's implemented, throughout my sort of, I guess, or so far as I've done, different keynotes on AI or done even tutorials or workshops. There have always been a couple of standard misconceptions that I've seen. But of course, I'm sure you have a very different perspective and lots of different experiences. So something that I'm wondering would be, as you've gone and helped clients with their, AI machine learning journeys, as you've gone and actually helped people implement machine learning in their use cases, what are some of those common misconceptions or misnomers about the world of AI, ML, that you see that you think are really important to debunk?
I think for a lot of people who don't understand how the technology works and who also watched the same science fiction I did, they took away a different lesson. They took away a fear that perhaps AI somehow replicates people, when in reality, it's a learning-based system that replicates things people can do. It doesn't replicate us. And so, for example, most systems that work on image and video analytics, these are machine learning based algorithms. They're trained with data, and they might be able to tell you if the paint on a part is defective or not, or if lots of people are standing near each other in a public place. Maybe social distancing isn't being done. You can see those things with AI, but it doesn't mean it understands what to do about it necessarily. And so it still relies on people making decisions. But I think what's really been the misconception is people thought it was replacing people in making decisions, when really what it's doing is informing people who make them. So if you're a business leader, if you're running, or if you're responsible for safety in that public place, you could watch all the cameras and look at all the people, and it's an enormous amount of data and work. But if you had an AI that was watching where people are moving, where they're going to be in 5 minutes, when they might be clustering together, and you might be able to keep social distancing going, you can save lives. AI could do that at scale and help you make a better decision. So you don't have to spend your time scanning the cameras. You can focus on the insights. And I think that's the biggest misconception is people think it replaces decision makers. It actually augments them by providing really actionable insights. So you don't have to look at all the data. You can look at what the data means.
Okay, so what you're saying is we're able to extract insight and meaning from data at scale, right? And so instead of us having to sit there and sift through, gigabytes, terabytes of data and try and find meaning, we can just take that meaning and then do what we want to with it, right? So it's automating that one step. I feel like that's actually a really elegant way to put it because, maybe actually going back to your original sort of statement here, with machine learning algorithms, we can replicate almost, even replicate's a bit of a stretch, right? But we can almost simulate, I guess, things that we as humans could do with computers, but we're not simulating the humans themselves, right? The way it gets the job done is completely different, right? There's no understanding of the job intrinsically. And my favorite example here is the Apple Watch with their fall detection, right? Of course, there's a machine learning algorithm going on there, but it's not like the machine learning algorithm understands that you took a fall and we got to call emergency services. It's just looking at the accelerometer and gyroscope data and saying someone took a fall, and then another human-written system is taking that binary classification and then launching a process on the watch that calls emergency services.
Right. It's an abstraction of real life. It's not real life. And I remember we were doing a lot of Fitbit contests, how many steps people could do. And then people realized they could just strap it to their dog and get lots of steps. It didn't actually know what was happening. It just knew that the algorithm was identifying steps in people. But I think this idea that systems understand the way we do is really, sure, it would be nice if someday that were possible. But you can see how fragile systems actually are. And that they don't really understand. When you can fool them as simply as putting a Fitbit on your dog, that's fooling an algorithm. There's lots of ways to fool algorithms. It's kind of like, when we look at images and as people, we're fooled by them. That happens. But in AI, it happens much more easily when you go outside of what it was trained upon.
Yeah, and I feel like that's something that is really important to understand about AI is that they're very sensitive to the distributions of data that they've been trained on, right? And it goes from a research scale to a production scale, in my opinion, right? Like maybe a good example would be, in research, like for language models. The way language models are trained is, you take some text and you train it to predict the next word and so on and so forth autoregressively. And then when the inference then is done autoregressively. So then you feed in a word, the network generates another word, and then it feeds it back into itself. You see, the issue here is that these language models are trained on a distribution of human data, but then during inference, you're feeding it its own data. And even that little change between, human-written data and language model-written data makes enough of an impact that the language model doesn't generate coherent text, just because that distribution is different, right? It still works on a high level, but it's not perfect.
You can understand this when you think about small talk. People use small talk all the time because they don't actually have to think about what it means. How you doing? Are you working hard? Hardly working? That kind of stuff. It's stuff people say, but it doesn't have a lot of meaning. But when you talk to somebody who's truly interesting and deviates outside of the normal conversation, they're not just a casual greeting, but they actually want to tell you something important. That's unpredictable. And so if you ran those same natural language algorithms and fed it data, how you doing, and we say the same things. But if something urgent happened, and you say, how you doing? Not bad, but my house is on fire. That's an unexpected answer, but actually requires great urgency.
Yeah.
And so if we relied on AI to predict everything people say,
Mm-hmm.
we would miss the urgent, interesting moments. We would only capture the benign, predictable stuff.
Mm-hmm. Mm-hmm. Okay, so I mean, it's interesting to see just how sensitive this sort of machine learning is to the input data that we provide it, right? With the sort of
Yeah.
sensitivity that it has to the distributions that it was specifically trained on. And so
Mhm.
when we do something unpredictable, the machine learning algorithms kind of just go haywire. And, they're not
Yeah.
trained to deal with these situations, and so they can't.
Yeah.
So, recently there has been an event I mean, pretty major in human history, actually, and that is, of course, the pandemic that we're in now, unfortunately.
Yeah.
So I'm sure that this pandemic has very wildly changed distributions of data that we generate. And
Mhm.
since so much of our society is run by machine learning algorithms, a question that I have for you now is, based off of your experience, what are some of the impacts that the pandemic has had on those fragile AI algorithms? I mean, they can't really adapt. They've been trained on, a world before the pandemic. Right as the pandemic hit, right as the lockdown started to hit, what were some of those, indicators of machine learning algorithms just kind of not knowing what to do?
Well, it's a perfect example of the predictable versus the unpredictable, and this
Mm-hmm.
is certainly an unpredictable time.
Mm-hmm.
Normally, you could predict how much toilet paper to produce any given week, every given quarter, any given city, because in the past, behavior hadn't really changed. Suddenly, it changed dramatically. People began hoarding out of fear, and out of fear drove up demand beyond supply, and then that creates a ripple effect because you can start to empty out the shelves at Costco, and suddenly no one has toilet paper.
Mm-hmm.
But then you start overproducing it because now you have to produce it for this new unexpected demand. And then pretty soon you're sitting with warehouses of toilet paper and demand has come back to normal. And then now, this week, I noticed that demand has gone up again and people are starting to hoard again. So the fact that human beings are inherently irrational and generally, in a time of great change, will respond in unpredictable ways,
Mm-hmm.
the algorithms that predict supply and demand no longer work. I would
Mm-hmm.
I would argue that almost every consumer supply demand model is broken now. And for companies that figured that out quickly, they were able to adapt. I work with convenience stores and soft drink companies and sporting goods and restaurant and casinos, all of these kinds of companies. Obviously, their lives changed dramatically.
Mm-hmm.
So when you take the data that they had and the models that they had, you have to look and say it's probably no longer sufficient.
Mm-hmm.
So most companies realized they didn't actually have the data they needed. They had the data that was good for the past. So this changed, in part, it changed the algorithm, but it actually changed the need for data.
Mm-hmm.
So more people are bringing in external data, third-party data, other stuff outside to bring it together to create better prediction of what people
Mm-hmm.
actually need.
Mm-hmm.
What are the leading indicators, for example, of spikes in panicking? You might see people buying more fever-reducing medicines or cough suppression medicine before they're even diagnosed because they begin to have symptoms.
Mm-hmm.
So those are leading indicators. You have to look further upstream at leading indicators. You can't just rely on, demand signals that you typically had looked at in the past.
Mm-hmm. Mm-hmm. Okay, so what you mentioned around being able to incorporate more third-party data is really interesting to me, and the reason I say that is because what my sort of as a machine learning developer, sort of
Yeah.
what my viewpoint is that suddenly all this data is shifting. Machine learning algorithms are no longer making the right predictions, right? Like for example, supply demand predictions
Yeah.
completely break down during this time, right?
Mhm.
Demand really spikes up. Suddenly, no one's hoarding anymore. Suddenly, people are doing it again.
Mhm.
That's unpredictable. And as a machine learning developer, my question would be then, well, sure, data changed really quickly. There's nothing we can really do about it. Machine learning algorithms, at least today, can't really deal with this. Then what can we do to actually go ahead and potentially train AI machine learning algorithms in, I guess you could say, more real time or quicker as we start to capture more data,
Yep.
right? So being able to at a very short term scale take new data from systems, and be able to train machine learning algorithms. Have you seen any work towards actually making it so that machine learning algorithms can be trained more quickly to be able to respond to sudden changes in data? Is that something that we do?
Yeah, certainly. So there are newer techniques, one called evolutionary AI, for example, that allows it to be trained on an ongoing basis with as new data comes in.
Mm-hmm.
So we took that same technology, applied it to the publicly available data about COVID,
Okay.
from Oxford and Johns Hopkins. It shows the new cases every day by country and by city, by state. And as that data evolves and changes, we're able to feed the model, retrain it constantly on new incoming data, and get a more accurate, forward-looking view. But you also have to do more. You have to look at causality, which data has the highest causal impact on the outcomes.
Hmm.
Techniques like evolutionary AI help you see that. So you're not chasing the unimportant data, you're focused on the important ones.
Hmm.
In the case of COVID, for example, school closings, work closings had a much more causal impact than international travel bans, as an example. So if you look at the wrong data as an indicator, you're really not seeing what's happening.
Hmm.
But when you look at the data that has the highest causal relationship, you can see it. And it's not the same everywhere. In some places, school and work closings had a bigger impact than others.
Hmm.
So being able to know that means you can watch for those as indicators of what will happen.
Wow.
So causality and I think evolutionary AI techniques to allow an ongoing learning model are much more flexible because when the conditions change, for example, when the vaccine is available,
Hmm.
immediately the number of cases will change
Hmm.
in given populations based on those rules. The same causal factors like work and school
Hmm.
will have less impact when the vaccine's available. The
Yes.
predictions will begin to change.
Hmm.
But if you built a rigid deep learning model
Hmm.
and just kept feeding it data, it will get confused when the conditions change dramatically and a
Yeah.
vaccine is introduced.
Hmm.
So you have to watch for those things and let a system adapt and learn as it goes, and then it will do an ongoing prediction based on new data.
Wonderful. Wonderful. So it's not just that training regime, it's also, having better algorithms that are meant to work with data that you know is going to change. I feel like actually that is, again, a property of the data and sort of factors into your decision as to what algorithms you choose, right? Because if you know for a fact that this is going to change, right? We're going to have a vaccine soon, maybe there's a mutation of the virus, whatever it is, we want an algorithm that we know can adapt quickly to these major changes, which is where something like evolutionary AI comes in. But then, if you have something where you can be reasonably confident, it's not going to change, something like, Apple Face ID, I mean, even that's a little debatable, but something like Apple Face ID, right? People's facial structure isn't going to, remarkably change in the next 10 years.
Except masks got introduced.
That's what I was mentioning, yeah.
Yeah. So you think that's a nice stable thing. Faces are similar, but then all of a sudden, masks show up and facial systems are not as good.
Hmm.
So then you have to retrain them to focus much more on the areas you can see.
Yeah, and then, there's all the issues around, is that even accurate enough now? Maybe it's actually more accurate to go back to Touch ID now that we can't look at the whole face, right?
Yeah.
And so, there are all these different unpredictable things that, we simply couldn't foresee. And so that definitely sort of factors into the whole idea of how do you even choose what models to use in the first place, right? It depends not only on that data, but also, do you think this data is going to change remarkably in a short amount of time? Mm-hmm. As a matter of fact, we actually have a question from the live stream that I'd love to take up before we continue. This is from Prasad Loke on the YouTube stream. Mm-hmm. He's saying that most of the analysis that I see on YouTube is all just data which has already been analyzed and we know it works. And so I assume what he means is that, in different tutorials or different, platforms where he learns about machine learning, all he sees are examples of analyzing data where we already know what that data's structure or what the insights are. So things like the IRIS data set or the MNIST data set, we already know these things. So what he's asking is, how can we solve problems when data is new and it's hard to or how exactly can we understand it and implement models with high precision? So how can you sort of generalize what you learned from these examples where we've already done the analysis to implementing to new models on new data?
So we do this all the time. Every situation we have is something new to learn. If it was out of the box, anybody could do it. So these are hard problems. One of the problems we worked on was with Mount Sinai Hospital, looking at when patients are in the hospital, how do you determine if they're likely to, after they leave the hospital, get proper care or be readmitted? And there's a ton of things people say during the course of care to a nurse or a doctor that is normally written down or put in an iPad and kind of left to the side. Mm-hmm. But we realized that they say things that actually indicate whether they're going to get proper care or not. So this was not a model that was already built. We built this. We used natural language processing. We obviously scanned and digitized or whatever the text, and then ran natural language processing looking for words people say that are determinants that they might have an issue. Either they live alone, they live up a very long walk up, they don't have a car, they live far from things. Maybe there's violence in the home. Anything they say during the course of care can be a determinant whether they're likely to get follow-up care. And the hospital figured out that one of the things they could do is either do, delivery of medicine or give people Lyft vouchers so they could get to the pharmacy to get the medication. If you take your medication, your chance of getting back to the hospital is much lower. If you can get follow-up checks and visits, your chance of getting serious is much lower. We can save lives just by understanding people better. And that was one of the cool outcomes. And there's no model for that until we built it with the client and with the data that they had.
Okay, and you know what I actually love about that example even more is that that's a kind of insight that is, I wouldn't say counterintuitive, but it's not necessarily intuitive either, right? Like if you were to just sort of sit there and do, an analysis without actually looking at any data, without actually, looking into it, if you were to ask for the budget, from an executive to give all these patients, Lyft vouchers to actually go and get their medicines, the executive would be like, no, why? Why should we give them that budget? But when you can actually point to the data and say objectively that, hey, we're going to save X amount looking at this data if we do end up giving them these vouchers, I feel like that is really impactful.
Yeah, that's where you start connecting the data across instead of looking at specific things. Everyone looks at how can I make something cheaper when they really want to focus on the total cost of ownership or the total cost of care. Or some companies just care specifically about client, satisfaction and the lifetime value of clients. And how do you optimize that? Individual decisions don't do it, but the aggregate might.
Absolutely. It's all about lots of little micro optimizations that work towards that better, larger system.
Yeah.
All right, now there is also another question from Cecily that I think is really interesting because it kind of ties into our, discussion around, what are these misconceptions that we have about AI? How do we think about AI technology? And Cecily's asking more generally, how does technology impact human thoughts, feelings, and emotions? And there's also another question, but we'll get to that one second. But maybe we can also talk about AI's impact specifically, but also how do you think that technology is sort of impacting the way that we think, the way that we feel, and our emotions?
We evolved through thousands and thousands of years of not having technology. And this is not AI, this is really about tech itself. You and I right now are doing live video. In a perfect world, we'd be having coffee together somewhere in a coffee shop and talking about this stuff, and it would be natural and easy. Instead, we have all learned how to adapt and deal with a different technology presence around us. I think the bigger issue, though, is the amount of data that is now presented to us is substantially higher. In that pre-tech world, your world was small. It was your neighborhood, it was your town, it was your, you ran a store. It was finite in scope. Data didn't change very rapidly. But now we're barraged by data. We are effectively our own AIs trying to absorb all this data and get meaning from it. We rely on tech now in a way that I don't think most people realize. It's like slowly boiling in a pot. You don't realize it's boiling until it is. We're at a point now, I'm sure, you wouldn't be able to use a paper map and navigate a city. That would be a ridiculous thing for you to do. We have live GPS systems. You don't need to do that anymore. But we've lost some skills along the way as we focused more on how to bring meaning to data. The cool thing about the GPS example compared to a map is that now all that data is coming in, including traffic congestion and stuff from social, feedback and systems. So live, you're going to arrive at 8:15. You know that, and it's likely very true. You're reliant on it, but you're consuming all that data and you're using an AI-based system that turns the data into insights and prediction, which then you're making better decisions on. So you can leave, exactly 45 minutes before your appointment because you know when you're going to arrive. You take out the buffer, and now suddenly we're all, very hyper efficient. You leave on time, you arrive on time, you're using data and AI constantly to inform you to make decisions. Get off on this exit, take this detour, now is safe to stop for gas, whatever those things are. It changes the way you think because you're now reliant on it. It's augmenting our day-to-day decision making. How many people travel and don't know the weather in the city they're going for the next, 10 hours ahead of time? I know it's going to rain at 2:00 today. I know that. So I'm planning some stuff before 2 outside. That's very precise. But before technology, how did people know that? They looked up, there were clouds, it might rain. I think we've become more precise, more reliant on it, but also better at knowing which inputs matter. Like, for example, the trusting a GPS or trusting a weather system. There's things we can now rely on more as well. And then I think from a human contact point of view, 2020 has probably demonstrated that we are social animals by nature, And even though this, doing video conferencing is not quite the same as being there in person,
Hmm.
we're doing it at scale
Hmm.
because we need to interact with people. We need to share and talk and listen and have questions, live questions on a Sunday, which is really cool.
Absolutely, right. It's all about that human interaction. And I gotta say,
Yeah.
fundamentally, you're right. We are social beings, right? We need human interaction. We quite literally, physically cannot live without it, right? The way we've evolved has made it so we are physically dependent on being able to interact with other human beings, which makes sense from that evolutionary perspective. And I feel like it also makes sense that the way we evolve really shapes the way that we think today about technology, right? I feel like even if we were to take exactly what you said and sort of apply that logic to AI, if you think about the way that we think about machine learning and AI, how people think it's intelligent and stuff, it's not really because we as humans are sitting there thinking yes, these mathematical algorithms are intelligent, they're human-like, but rather because the emergent sort of behavior from these systems that we put together tricks our brain into very easily saying that, hey, this has to be intelligent, right? Because our brains don't deal with technology, right? Our brains have never had the evolutionary, need or cost to evolve a different center to deal with things that aren't really alive, but deal with things like natural language and visual data. As far as our brain is concerned, if something processes language, it's a human. So,
Right.
I mean,
You know,
go ahead.
well, so my first foray into computers, my teacher came to school one day and said, I went up to a computer. It said, "What's your name?" He typed his name. It said, "Hi, Ted." I was blown away because I thought you could train and teach a system. That's what got me hooked on this from the start.
Yeah.
And now we talk to computers all the time and they talk back, and people do feel like it's understands. People think that, Alexa and stuff learn from us each day.
Hmm.
There are people in rooms who are learning from all the aggregate input, but it's not learning each day in your home.
Yeah.
But it's getting better over time as people make it better. But it's the person behind the curtain.
Hmm.
AI by itself is not doing all this. There's also a ton of people who support it by feeding data, selecting data, tuning data, training models. There's a ton of human work that goes into making AI effective, and it does create a bit of an illusion of being more human than it is. But that's because we need to interact in ways that feel comfortable.
Yeah.
Why do we like, a voice assistant in the home or in our phone? Because it's comfortable. It's better than reading, nobody wants to read binary code. They want to hear. And as expressively as possible, an answer. Is it going to rain today? Oh, I'm sorry, it's going to rain today, but make sure you bring your umbrella. Like, we would love an answer like that.
Yeah, yeah, absolutely. It's all about being natural, right? It's all about, because again, human interaction is comforting to us, right? And so we want
Yeah.
to have that sort of pseudo human interaction, but it's at scale, right? You can talk to Google Home or Siri whenever you want to, but you can't just go up to literally any human whenever you want to and talk to them necessarily, right? So
Right.
it's kind of like giving us that comfort at scale almost. I feel like that's really interesting. Even though I develop, a lot of these machine learning algorithms, I'll talk to my Google Home, and there's that little thing in the back of my mind saying, you know, this is oddly natural, right? It still feels weird to me that a technology system can be that just intuitive to talk to and listen to, but it can, and that's something that we gotta sort of drive in, is that these are not intelligent systems. The behavior that emerges from them, thanks to human training and development, may look as if it's intelligent, but it's not.
Yeah. Do you have a Roomba in your house?
No, unfortunately.
So I do, and I'll tell you, almost everyone who has one names it. It's the first thing they do. They give it a name. I think the app even encourages it. So, and I've looked on Reddit and I saw the people sharing their names of their Roombas. And then there was one guy who actually put a little wiggly tail on his Roomba. And we want these things to feel as close to alive as possible and
Yeah,
to appear intelligent.
that
And I
is.
think AI has crossed a lot of barriers on that. And natural language is an amazing thing. Look at GPT-3
Yeah.
and its ability to generate text. It's really kind of amazing.
Hmm.
But it's not a replacement for Tanmay. It's an augmentation because you can use that and then make something even better.
Thank you. Yeah, no, absolutely. Hopefully AI doesn't replace me on TechLifeSkills anytime soon. So, yeah, no, I totally agree, right? GPT-3 and all these other technologies are about, in a way almost mimicking, I guess, very basic tasks that our brains extrapolate to real intelligence. But
Yeah,
actually, speaking of GPT-3, um,
yeah,
natural language processing and even language models in general do exhibit quite a bit of bias, and bias is an unintended consequence of AI machine learning development. As a matter of fact, we have another question from the audience from a very special attendee, John Cohn. Hi, John. Thanks for joining today's stream. Also, everybody, really quickly in the live chat, I'll post a link. John and I also did an episode on TechLifeSkills some time ago, so I'll put a link to that. It's really interesting. We talked all about the world of IoT and even a little bit of AI, so make sure you watch that. But John's actually asking us, how do we teach AI practitioners to be sensitive to unintended consequences? And also, John's asking us, did you see the Social Dilemma? If not, watch it. I unfortunately haven't watched it, so I will. But Bret, have you watched the Social Dilemma?
Oh, I have.
Okay.
And good question, John. No, it's fantastic because I think what it expresses for all of us is the power of the data and how much companies do know about us. Mm-hmm. And there's a lot of reasons for them to know things. It makes us able to personalize systems, things like that. But there's also a lot of risks and dangers to it as well. I do recommend the movie. Back to the bias point, though, I think the best way for anyone working in data science, machine learning, AI to deal with bias is to first recognize that every one of us is biased. Mm-hmm. Every human being has existed with inherent biases. We build a model in our head from what we observe and see in the course of our lifetime. And we also have social norms around us as well on what biases are acceptable or not. And I was reading an article this morning about bias, and it was interesting because if you don't create a mental model, for example, touching fire is dangerous. Am I biased against fire, or am I now aware that fire might burn? Mm-hmm. It doesn't always burn, but it might. And so we build a mental model, but those mental models extrapolate into areas which are unacceptably biased. Mm-hmm. And makes us, discriminate in one way or another against people. And so when we build systems, we have to recognize the systems are built by people, and data that is, as we talked about earlier, a representation of people's behavior. So if I were to, only pick a model that says, Amazon did a recruiting model that's very publicly famous, mm-hmm. Where it looked at past performance of candidates. And I looked for characteristics in resumes that matched past performance. But if the workforce was not diverse to begin with, the performance wouldn't represent diverse people.
Yeah.
Job descriptions are notorious for being written by people from their own point of view. We like people who are like us. So we generally write a job description that is representative of how we think, what we look for. But diverse candidates self-identify differently and promote themselves differently. Mm-hmm. And so job descriptions can encourage bias and can limit inclusion. So my point of all this is it starts with human beings recognizing that we are inherently biased and to look for outcomes that would be good. Mm-hmm. If a good outcome is to have the most diverse workforce possible, you would want candidates to be representative of the population. Mm-hmm. And so you'd have to make sure that at every step of your systems, you're looking for outcomes which are representative. Then you can balance your models and tune for it and account for it. But if you don't, you tend to reinforce the human biases, the language, the words, the filtering that we use that basically precludes inclusion, for example.
Mm-hmm. Mm-hmm. I love what you mentioned around, being able to understand that, first of all, bias isn't just something that we program into systems necessarily purposely, but just that we as humans are fundamentally biased. And I'll talk about that in a moment, but we as humans are fundamentally biased, which leads to the fact that the data that we generate sort of has that bias and imprint on that data. And then that data, when fed into machine learning algorithms, which themselves may not be built with the idea of being able to minimize that bias, sort of, makes the problem worse.
It does.
Now, one of the examples that I really like is that one experiment, and I'm forgetting who conducted the experiment, when it was, but there's this one experiment about pigeon superstition, and how they would give pigeons food at random times. Literally, there would just be a little, I believe, like a little hatch that would open up at just completely random times, but because the pigeons didn't know it was completely random, whatever they were doing, if they were like slightly, scratching their feathers or something, at the time when it opened, they would assume that there was some sort of correlation or some actual causal link between them mm-hmm. doing that thing and getting more food. So they would just keep doing that over and over again until they got more food, which continued to strengthen their sort of bias. Mm-hmm. Because they were looking for that connection, right? They were like, oh, this did it last time, let's keep doing it. We got more, it probably was that. And so I feel like human bias is also very similar in the sense that there are a lot of things that do make sense, right? Like, for example, as you mentioned, you touch fire, you're most likely going to burn your hand. That kind of bias, that kind of link, yeah, that makes sense. You know, if I jump, I'm going to fall eventually too. So if I jump off a cliff, you know, if I can sort of imagine what's going to happen. But then there's some other kinds of bias that we have that don't necessarily make any real sense, but just because our brains have seen some kind of correlation somewhere, or we've tried to convince ourselves that this correlation, we also start to see that causal link that isn't necessarily there. So that's an unintended consequence of developing machine learning, but I actually want to take a step back and maybe actually look at John's question once more. And that is that actually, first of all, one more example that I really like, and this sort of relates to John's question, is the Pulse network developed by a couple of researchers for facial upsampling, being able to increase the super resolution sort of increased resolution using a super resolution algorithm for faces. Mm-hmm. Now, this algorithm was very biased to generating, middle-aged white male faces, and so you would give it, an ambiguous, low-res photo, and it would generate, a very stereotypical, average face. But that wasn't necessarily because the researchers behind the algorithm were like, oh yeah, we want to generate these faces and code it that way. Of course not. It's because the data set it was trained on from Flickr just had a lot of those faces. So that's an unintended consequence. And so John's question is, how can we actually teach the practitioners of these AI technologies to be more sensitive to those unintended consequences? And that's something that I'm really curious about. So how do you think we can encourage the actual machine learning developers to think more about how to solve those issues?
This is why the point earlier about focusing on the outcomes is so important. Mm-hmm. The same example you just gave happens if you search for the word grandfather in Google Images. They all look the same. It's not diverse at all.
Yeah.
And it's just because a lot of the training sets that have gone in are older training sets before the workforce or others might have been more diverse, or whatever the reasons were. People picked the images and labeled them, and that's how it came out. The trouble is you need diverse thinkers in order to ensure that you're not missing these things. You need diverse data sets. And you need to ask yourself if you're really using a proper representation of the data to even do it. If you train, an image database with Flickr images that might have been done heavily by a certain demographic, you're missing the entire rest of the world that isn't using Flickr, that might have had different, images of what a grandfather looks like, mm-hmm. and making sure that that's truly representative. So I think it first comes from being able to ask the right questions. Is the data coming in representative? When you go to recruit people, and if you only go to agencies that cover certain cities or locations, you're only going to get one demographic. You have to ask yourself first, are you even looking at the proper input pool? Mm-hmm. Data or people or whatever. The second thing you have to ask for is the criteria you're looking to evaluate diverse. The people doing labeling, are they a bunch of college students in the Midwest, or are they people globally who are looking and doing the labeling? Mm-hmm. And that will also skew the labeling itself, which then skews the weighting of the model. Mm-hmm. And then you need business leaders who sponsor this work to make sure that the output is actually representative of what you're trying to get. People who are looking at image search, they should probably look at that and say, well, maybe I really want a more representative set, and then go back upstream and go figure out if it's a data labeling issue, data source issue, or human bias that's being infused in the system somewhere. But I think the biggest problem people have is that they delegate these kinds of projects purely to the data scientist. Mm-hmm. And they don't take responsibility for recognizing that the output is what matters. Mm-hmm. When you hire someone who does recruiting, if you hire someone who is biased and it shows up in their behavior, you fire them. If you build an AI that is biased in its recruiting, you didn't measure it properly. You didn't mm-hmm. watch. So mm-hmm. it's a responsibility for leaders as well as for practitioners.
Very nice. I love that, right? It's not just the practitioners that have to sit down and figure out how to minimize that bias in the models themselves. It's about the output of the AI model in the larger system that it's a part of, right? It's not just the practitioner or the developers or the researchers at Google going over and saying, how do we map certain natural language queries to images? How can we make that less biased? It's also up to the leaders at Google to be able to say, we look at this whole system of Google images, and this AI model is a part of it. how can we make it so this output's less biased? Look at every stage in the pipeline and where bias may have come in, and see where you can figure out how to get a more sort of representative sample. And of course, bias isn't even just about these human attributes, right? It could be as simple as, if you train a neural network to predict a jet engine failing, but you have a lot more data for Rolls-Royce engines failing than you have GE engines, then it's always just going to think a Rolls-Royce engine's going to fail, right? It's all about generally data representation. It's not even just about human level bias. It's about all these different ways of collecting, labeling, cleaning data that I think leads to bias.
Well, you're also on an interesting point, and that is bias itself isn't bad, because bias is about difference.
Yes.
The question is that is the outcome damaging? Is it harmful to certain groups? Is it harmful to your brand? Is it harmful to people? Or is it helpful and informative in what you're doing? I knew growing up that 17-year-old boys had higher accident rates than 17-year-old girls. I knew my insurance rate was going to be higher than my sister's. I knew that. I lived with it. It was acceptable. If we eliminate all differentiation, the model will simply say, it wouldn't even be based on age or gender. It would just say human beings have this many accidents. My rates would have gone down. My sister's rates would have gone up. My grandfather's rates would have gone up. Like, the average rate would have still been the same, but for different groups, they wouldn't have gotten the benefit of being in a safer category. So being able to recognize risk, for example, is not necessarily discrimination. It's simply recognizing the difference in risk. And models then become useless if there's no differences. The challenge is there are legal protections that must be enforced, and the people working on data science need to recognize what is legally protected. For example, discrimination in hiring or renting, or versus differentiation in rates, for example. Now, there's another thing going on, though, which is hyper-personalization, which actually moves us past bias into making it all about you as an individual. So Progressive Insurance and others have put a dongle, a thing you can put in your car, and it tracks your driving behavior and other people's driving behavior, but then it tailors your rates to your driving. Then you basically made it a use case of one, which is really cool, because now you're not discriminating on me being male or my age or anything else. It's just simply my driving is so much better than yours that my rate should be lower.
Actually, I love that example of the hyper-personalization, because I feel like it's a great example of where machine learning sort of helps us eliminate a lot of bias in this case, right? Because if you think about it, what are we trying to do by saying you're 17 years old, you're male, you live in this area, and some other attributes? What we're trying to do is we're trying to map, hey, based off of these aspects of your life, maybe we can predict, different other attributes that would lead to a certain way of you driving. It's not necessarily a one-to-one mapping. It's not necessarily that, you are a 17-year-old male, therefore you will drive this way. But using that data, it's possible for us to make some sort of, first-order assumptions as to what your life might be like, and based off of that, predict, you're going to be relative to this other person 2 times less or more safe. And so change the rates that way. But then, what we're really trying to do is not look at those attributes, but look at the sort of causal link between those attributes and your driving, which leads to the rates, right? So if we can skip those attributes altogether and use machine learning to understand your driving directly, we've solved the problem. And so, I feel like maybe... I feel like that actually was a great example, is that, instead of having to look at those other attributes through which we infer other attributes to make a final prediction, if we look at those attributes directly, we're good to go. Kind of like how Tesla, can actually map your driving and figure out based off of the way you drive whether or not you deserve to get the full self-driving beta. So
you're on exactly the right point, and that is that up until now, because the data was hard to get, or hard to comprehend, it was very hard to create that level of personalization. But that is ultimately what we all want. Nobody wants to be in a segment of 18 to 24 or whatever. Nobody wants to be in a labeled group. You want to be known. So your buying behaviors and your patterns and your lifestyle, but you want offers that come to you that are relevant to you, not to your demographic. Nobody wants to be a demographic. They want to be a person. But there is a balance to that also, because there's a huge data privacy implication that the more I know you, which goes to the social dilemma discussion that John had, the more I know about you, the more danger there is for that information to be abused. So a lot of the discussions in the industry go around, how do I create hyper-personalization, increased understanding of you, and at the same time ensure protections of your data, and ensure that the intended uses of the data match to how you provided it. So as a driver in a Tesla, for example, they may know everything about you to enable whether you get access to that data or not. But do you really want them selling that data to your insurance company and then raising your rates? Because that's an unintended use of your data that you didn't authorize.
So being able to understand not only what kind of data that a company's collecting on you, but also why exactly they're collecting it and how they're going to use it, I think it really sort of ties into this angle here. And when it comes to this data, before I continue, there is one thing that I want to mention, but we'll get back to that in a moment. Another question that I have for you here is, it's almost, how exactly could we phrase that trade-off between, as a user, I want value comes from me giving my data to a company, but at the same time I lose value because then I have to share things. Maybe a good example would just generally even be the way that Apple does compute. There have been all these different articles from people that are these privacy advocates and stuff, where they're like, technically your Mac computer you don't own, right? Mac OS, every time you open an application, is verifying the signature of the code of the app against an Apple server, and it's doing all these things, and your computer shouldn't be doing that. Your computer should be telling or just doing things for you. Why should be telling Apple what you're doing? But at the same time, there's this other side of people that make the argument that, well, yeah, Apple kind of has to do it, otherwise we'd have the same amazing malware situation that we've got on Windows. So, there's that trade-off where, yeah, you're giving Apple your data, and technically, because they're part of this, they've got this contract with the US government, they could technically give that data over to the government whenever they wanted to, or whenever the government wanted them to, actually. But at the same time, you kind of need it to avoid all the malware and the problems that you got on other platforms like Windows, which is the whole differentiating factor of Mac in the first place. So there's all these different things to look at, which can almost be stressful as a user. How do you determine, yeah, I want a great virtual assistant to be able to interact with, but at the same time I don't want Google or Apple listening to my audio recordings. As a user, how do you make that kind of trade-off? Because it kind of seems weird. And as companies, what can actually organizations do or governments do to make users trust them more, to make it so we get enough data to provide good value?
That is a massive question. That's a massive question, of which I don't think there's an answer, but there's a lot of discussion in the industry going in a lot of different ways. I think one part of that, to unlayer it, is the end user has very little understanding of how their data is used after they've given it. So how many people read the end user agreements in software or on apps, or you can't read it. We have very granular controls, but nobody knows how to do all that and limit their use. So I think part of it is that it's a little bit of a trick right now by putting it in fine print, giving it to an end user and saying the end user said it was okay, therefore I can do whatever I want. I think there is a discussion in the industry about more of almost a bill of rights on the use of data, and that we should have an understanding of how our data is being used. The example you gave that, Apple may know a ton about us. What if the government insisted on them giving it? There have been cases where that occurred and they refused to give it to unlock phones for the government. I'm not going to say what's right or wrong, but I think as a user, if people start to become unhappy about the unintended uses of their data, they will flock to systems that don't share. And those systems might have other limitations and constraints. We do have choices on what systems and things we use. But I do think companies also have a responsibility to be transparent about how data is used, where it's shared. There's a trick some people use with their email when they sign up for things. They attach something at the end of their email address so they can know who they sent it to, and then they'll see where it was shared. Yeah. So, Bret Greenstein, and .CarMax, and then if anything else comes in with CarMax that wasn't from CarMax, I know they shared my data. It's a clever trick, but who takes the time to do that stuff? So I think we should expect that if we gave our data to CarMax, it's so that only they can use it, not to be using it for cross-marketing or other purposes without consent. And that's what you've generally seen countries doing, especially in the EU, trying to make it more consent-based, but it's very complicated because you issue consent every time you click an app. It's like really tiring.
Right.
But I think ultimately personalization, creating value, does require knowing something about us. And I think there's a reasonable expectation of privacy. It's the same expectation that other laws protect. We need to have it in our digital world as well. Right.
And I gotta say, as a machine learning engineer, but also as just a person, it's so you kind of get torn apart thinking about this problem, because on one hand I totally agree that everybody should have complete transparency as to exactly how their data is going to be used, and they should have the approval to say, no, I don't want my data used for this use case, but it's okay for this one. But at the same time, as a machine learning engineer, I'm thinking, okay, let's just say we spend years capturing data for a specific use case, and that's all well and great. But then suddenly we have this brand new idea that this data could be used for on a completely different use case that would end up adding value to those same consumers' lives. Technically, we don't have the consent to use that data for that task. So it's kind of like, where exactly do we draw that line? But that's definitely something that we still got to look into.
Well, the pandemic highlighted that for all of us, right? I mean, every cell phone company in America knows exactly where you're standing, right? Whichever phone you have. They know where you're standing, and they know if there's anyone nearby standing. We could be tracking clustering and social distancing and doing complete track and trace, but it's been a really tough decision on how much of that data to be used for public safety and how much of it is private. Mm-hmm. And it's a discussion that happens, every day during the pandemic. Other countries made that data much more accessible, mm-hmm. and were able to track and trace more effectively. So here you've got human lives and the impact on society weighed against data privacy. Mm-hmm. It's happening in 2020 live in front of us. And there's real cost to freedom, but there's also a reason people fight for freedom.
Yeah, it's definitely a lot more of a complex question than we can necessarily answer on the live stream. I wish we could, but maybe a topic for part 2. So it's well, hopefully we can work toward, and hopefully this discussion has been helpful towards trying to work towards not necessarily a solution, but a new way of thinking about data privacy. But also, now, there's a question, slightly different topic, from HRS here on YouTube. And they're asking, can you please talk about how you can identify a project where machine learning can be useful, or where it can actually be appreciated by machine learning technology? So basically, how do we know that for project X, machine learning will be helpful?
It's one of my favorite questions, because I deal with this every day. We look at a problem and we say, first, is there sufficient data that exists that might be relevant to the outcome? The second is there a technology that could solve it? And third, does it have enough impact and benefit to be worth doing? And we look at that every time. We were looking at a problem specifically around recruiting and using AI to help drive improvements in diversity and inclusion, and to eliminate bias in the manual hiring. It's kind of the opposite of the question from before. And we're looking at that. Our first question was, do we have data which would be interesting and relevant to solving that problem? In this case, we had job descriptions, for example, and resumes. And those are, things that, if not handled properly, can introduce bias into a system. So we looked at those. We said we have the data for those. Second thing is, are there natural language or other AI-based techniques which could bias these kinds of things? Can you take the bias out of job descriptions? And it actually is technically possible to do that using natural language. You can also look for criteria that might be indicative of success in resumes that is not that removes the bias. There's tons of studies about how people self-report their own capabilities, and certain groups are more likely to put technical certifications, others are not. And so, if you only look for the technical certification, you're missing a huge group of high potential people. So you can de-bias the data for that as well. So first, is there data available? Second, is there a technique like natural language that might help you identify characteristics? And then third, is the problem important enough to spend the energy on? Some problems, a simple linear forecasting or a simple algorithm is enough. You don't need AI for everything. But problems like those, where the data is unstructured, where there's inherent bias that you need to eliminate, where it happens at scale, also where data is changing very rapidly, or where you need external data that's massive scale, like new types of data. These are all great things where AI is probably appropriate solution. Mm-hmm. But I also like the idea that sometimes the answer is simple. Yes. Sometimes a simple algorithm is enough. Sometimes a spreadsheet is enough. Knowing when you need more is actually the real science of data science.
Mm-hmm. I gotta say, I agree that sometimes knowing when not to use machine learning is part of the art of machine learning, especially with how hyped this technology is. There have been so many projects where, people will come up to me and be like, all right, we're going to use machine learning to do X. And I'm like, we really don't need to use machine learning here. And in a lot of the cases, we've actually tried both and we've gotten better results without machine learning than we end up getting with implementing machine learning related concepts. And in some cases, it doesn't even make sense to implement machine learning in the first place.
Right.
Now, maybe a good example where it kind of made sense, but we didn't anyway. Literally just yesterday, I was working on a project with a friend of mine. His name's Mike, and so we're working on this really interesting project that I'll be talking about more soon. But the idea is, it's in the field of biology, and we can see this image from a microscope, and we got to do, like, for example, line detection to be able to count cell confluency. And usual, or at least his first approach was, hey, what if we train an object detection neural network to figure out where the squares are, and then we can do the counting of the cells. But then what my idea was why train a whole deep learning algorithm and sit down and label data all day if we could just do a pretty simple canny edge detection and find the intersections of the squares, because we've got a pretty standardized data set, right? So being able to identify those patterns in data and be like, all right, these are the assumptions that we're working with thanks to our data. Due to these assumptions, we can simplify our solution to be this instead of this whole complex, pipeline.
Yeah.
So I feel like that's
every problem starts out with this idea: we could design a neural network to do X. It always starts with that, but then there's often a simpler thing, because what you're really looking for is what has the high causal relationship, with the highest likelihood that something is yes or no, good or bad. And to know that sometimes it's the simpler case. You don't need to do the harder case. But I think where you have high rates of change in data, where you have complexity, where you can't find that simpler thing to look for, you may have to really look at the whole thing.
Yeah, sometimes you really do have to look at that whole pipeline, see where the AI system's actually being implemented, what kind of value are we adding, and then figure out, do we want to use AI in the first place? So that's definitely important.
If you're looking for a needle in a haystack, a magnet will do fine. Just run a magnet. But if you're looking for a needle in a needle stack, if you're really looking for data that's really messy and often looks very similar, you do need systems that are more sensitive to change or differences, and that's where AI is more likely to come in.
Absolutely. Right. Now, another question, actually, this is related to what we're talking about right now, from Vignesh. He's asking on YouTube, is there a way that AI can identify manipulated data and help us correct that data?
So the same way that I would say, well, first, the answer is yes, but it does depend on how the manipulation was done. There's already significant work being done on detecting deep fakes. And it's not that different than techniques that have been used for years in looking at, for example, Photoshopped images. There are trails and traces of manipulation of data where patterns are highly repeatable. For example, in deepfake images, they've been able to, in video, they're able to look for example, the pulse on veins and eyelids and stuff to see whether the character was generated or real. The technique is not always the same in every case, but it can be done because machines are working on an algorithm. What you really want is to detect an algorithm. I'll give you an example. If you're flying on an airplane and you look at the map on the airplane, it'll show you're at 30,001 feet altitude. That's an algorithmic control. That is not a person. You know that because it's so precise that it's not a natural number. It's not 30,007, it's 30,001. It's so close that it's algorithmic. If you watch stock prices, every once in a while, they hover at a threshold. That's an algorithm doing trading and deciding that when it hits 28,000, sell. So you'll see that it gets to 29,999, doesn't quite get over that limit. When recognizing algorithms is actually an art in and of itself, as a science too. There's a technique to it. And I think that's what really comes down to how you identify these things, is to look for where algorithms are touching things, whether they're changing images, changing audio, things like that. We actually, as people, can tell when these things are happening. But when you do it at scale, when you're doing it like in, for example, deepfake technology, or if you're reading an article that was generated by an AI, there are algorithmic patterns to it as well.
Yeah, it's all about being able to figure out this pattern. There's always an imprint of whatever generated that data on the data itself. It goes back to what you said, right? If someone smokes, then just the way that they move their hands, the way that they gesture generally throughout their day can help us figure that out automatically, because that leaves an imprint on the way that you behave. Similarly, when machine learning algorithms are trained, they leave a certain imprint on that data that is detectable. It's just up to us to develop the algorithm algorithms to do that detection. Right? There's different techniques all the way from literally just feeding the face into a neural network and saying, figure it out with deep learning to see if it's a deep fake or not, to actually looking at, as you mentioned, the pulse on the eyes, or even just the rate of change of the blinking of the eyes, right, when they actually close, being able to determine if it's a deep fake that way. So there are lots of different methods to be able to make this more robust and be able to identify this manipulated data. It does get progressively more complex, right? Like previously with Photoshop, there were human imprints, which arguably were easier to detect. Again, arguable, whether or not that actually is the case. It's different on every, I would say, sample. But now it's really just changing, right? We're shifting the algorithms that we use to detect, just like we're shifting the algorithms that we use to generate.
It's interesting how much is new and how much is not new.
Yeah.
Detecting fake art, for example, looking at, is it really a Monet? Comes down to looking at brushstrokes and paint types and background. You're looking for those subtle differences from what's expected to what you actually got. And it's very hard to fake completely. And so we had to get more sensitive at looking at those things. And now people can tell that. They can even use AI to tell if something is fake or not, because they can look for those differences.
Right. And I mean, it's even, in some cases, AI is actually better at telling, or really good at telling when something came from AI and humans aren't, right? Like OpenAI built GPT-2 large, or sort of extra large, the one with 1.5 billion parameters. And humans, when they just sort of skim through it, can't really tell that it's from machine learning. When you actually read into it, you can pretty easily tell because there's just lots of logical inconsistencies. But then OpenAI was also able to build a simple text classifier using Roberta that could take any text and determine whether it came from GPT or from a human, right? It's not perfect, of course, but it just goes to show that there is a pattern there, right? It's a pattern that even other machine learning algorithms can identify. And so it's all about being able to identify that. And you're right, it is a skill, being able to identify data that comes from machine learning. All right, so now before I get to a question from Anandi, there is one question that I want to take from Sahir on the live stream chat. He's asking, and this is actually a really interesting question, what about explainability of predictions to the end user, say in medicine or in sales? Should that be a bigger criteria in the selection of machine learning models versus performance or fitting of the data? The reason that I'm interested in this question is because it brings up a really interesting point of, as the user, you want models to be explainable, but they don't add any value if they're not performant. And as a data scientist, you really care about making sure the models are performant. So how do you balance that? How do you make sure that models are explainable, but still work?
If I asked you to fully explain why you asked that question, it would take you forever to fully explain it. The inner workings of our own brain are not transparent.
Yeah.
And I think what a lot of people overemphasize is it sounds good to ask for transparency of machine learning systems because it sounds like the right thing to want to see. But nobody wants to see what's underneath the covers, and you would never understand it if you did. So what you really need to look for is, in explainable AI, can a system tell you why it made a decision? What are the factors that are the highest causal impact on that decision? Not every factor, and you don't need to see and inspect the full neural network to understand whether it was working correctly. But if I asked you, why did you go left versus right? You might be able to explain the number one or number two reason why you did that. Looked like less traffic that way, so I went that way. Or last time I went that way, it was pretty good. Those are high causal factors. There's tons of random things also. Something caught your eye, little things you don't even know aware of that caused you to go left versus right. When an AI system does something, we should ask it. We should know what were the biggest factors that overwhelmingly helped you here. But a good AI system is going to look at thousands of factors. It's going to run millions of simulations. It's going to generate a decision that is way too complicated to explain, just like we can't explain ourselves. We have a lifetime of experiences that led to the decision we make right this minute. And I can't explain all of them, but I can tell you that right now, I went left because it looked like less traffic. That's why I did it. Mm-hmm. And I think and I know that sounds overly simplistic, but in a lot of ways, most decisions are highly determined by only a couple of factors. Mm-hmm. There's many that go into it, but there's a few at that moment that became the dominant ones. If you asked me 5 minutes later why I took a left, it might be a different reason. But mm-hmm. at that moment, that was the reason. And I think we should expect systems to be able to explain the top reasons why they make a decision at any given moment. We've also been doing work in healthcare where we make healthcare decisions, we also have to track all the conditions that existed at the moment that decision was made. So if we asked why was the rate or why was that decision made on Tuesday at that moment, you could say, well, at that moment, the number one reason was this. 5 minutes later, it would have given a different answer. You need an audit trail of at least explainability. So I think expecting it is good. Don't expect full transparency. Expect explaining the top factors. And also, for some systems, we have to record that over time. So we have some idea of why you made that decision at that moment, so that you're not creating, some other auditable risk.
Right. And machine learning algorithms, have, at the end of the day, from a technical perspective, been at least somewhat explainable, with air quotes there, right? From the sense that, as a machine learning developer, if I wanted to figure out what areas of this image contributed to the features that activated the cat perceptron instead of the dog perceptron at the end of my network, I could do, a gradient-based class activation map and figure that out. But as an end user, do I really want to know why exactly it detected this as, a human face and not a different kind of face? As an end user, explainability is something that is really needs a lot of work and something that you can't just ask for immediately. Like, you can't just say make the AI model explainable, right? Try and figure out why it made a decision. You've got to be able to structure that explanation, structure that explainability in a way that it actually provides value to the user in the first place. Right. So I feel like that's definitely another challenge when it comes to explainable machine learning and AI systems.
It is.
Right.
It is.
So now we also have another question from Anandi, and this is a question that I can answer, but I also love to hear your thoughts on it, Bret, as well. They're asking, what is the best platform to learn machine learning and the prerequisites for it? I actually have a new YouTube series called Learn Deep Learning from Scratch. So I've already got the first 3 tutorials in that series out, more coming out very soon, so stay tuned for that. Apart from that, there are also some other platforms depending on what exactly sort of part of machine learning you're interested in. If you already know enough basic machine learning, you want to get to more advanced concepts already, things like cognitive class do exist, but my series, Learn Deep Learning from Scratch, sort of takes you from the ground up. But Bret, any ideas? What are your favorite resources?
Obviously, watching Tanmay's series is my best resource.
Thank you.
This is too dynamic a space to give a single answer. So I think what people should do is continue to learn from all available resources. What you'll see is the cloud vendors in particular, especially Microsoft and AWS and Google Cloud. They're all constantly bringing new technologies and techniques and tools together. And I think taking classes that help you with the familiarity of as things come out is very important. But there's a lot of really interesting niche work happening all over the industry. So you've also got to research and read papers. I think what's interesting about this space is that the really deep data science, people who do what you do, Tanmay, really playing with the technology, is a finite population. What I'm really interested in is over the next several years, the massive population, call it the 10 or 100x number of people, who need to understand what the potential of AI is, who understand what the potential of data is, so they can hire people like all of us practitioners to go do the work. And so those people are growing faster. The number of data scientists will only grow at a certain linear rate. There's only so many of them in the world, which makes it a very valuable skill. So keep learning. But the people who will be hiring those people and investing in those people and doing amazing things in business and in society with AI, that's a set of people right now who do not understand AI. And they're asking really bad questions. I worked with a customer who was just signed up for an AI-based system to do predictive maintenance on equipment. And I thought, okay, they understood what they bought. It's an AI-based system. They're going to do predictive maintenance. After the meeting, after contracts were signed and we're all kind of chatting and having coffee, he turned to me and said, what happens when this system decides it no longer needs us? And I thought he was joking. I really thought he was joking. He's a very senior guy, and he wrote a contract. I mean, he's paying money for this stuff. But he was terrified that the system he just was paying to build was going to grow smarter than him and no longer need him.
Wow.
And it showed to me a complete lack of understanding of the strengths of AI, but also the limits of AI. And I think for your audience, for everyone, we need to understand that better. So as business leaders, we know where to invest. We know which skills matter. We know what the technology will do for our business and what it won't.
Yeah. I mean, What happens when this thing decides it no longer needs us? That's an interesting question, and hopefully that conversation wasn't too awkward. But that was it's fun to see that even the folks that are literally paying for the technology don't completely understand what it means, what it's going to help them do, why they're buying it, that kind of thing, right? And
Well, they know it's important. They know it's important, and they know their peers are investing, but they're delegating a lot of the work to the data scientists, which I think is unfair, because what you really need is people who understand it enough to set expectations, to set good KPIs, to set the ground rules of what you want it to do,
right,
so that it will have high value.
right. And as a matter of fact, actually, sort of extending on your point, if you think about it with machine learning, right, things have changed so much, even in terms of like data, right? Like today we will collect so much more data than we would a couple of years ago because suddenly it has value because we can actually extract insight from it with machine learning. Maybe a couple of years ago we wouldn't have decided to capture a certain set of data, but now we will. And this has wider reaching implications than just, oh, we're capturing more data. Quite literally, organizations can be structured differently to more effectively use machine learning or AI now that we actually have that capability. And unless the people who are actually in charge of making these decisions understand the technology well enough, they're not going to be able to have that kind of competitive advantage. So I feel like it is really important for them, at every level to have some kind of understanding of what technology is capable of and, how, for example, AI machine learning relates to that. Also other technologies, of course, but I feel like AI ML is that one that is has that biggest hype to, or misunderstanding to value ratio, right? There's a lot of misunderstanding, but there's also a lot of value. So that ratio is, it's interesting for machine learning.
Yeah, I've seen this accelerate dramatically in the last 2 years with the emergence of the chief data officer inside companies. These people do understand the value of data. And what I've seen happen, and really over the last 2 years, but accelerated in 2020 with the pandemic, was the idea that the data used to be run by the IT shop and it was managed as silos, a bunch of buckets of data that were a cost. Everyone wanted to control it. But the data that's useful is often outside the enterprise, and it's useful across the enterprise. I'm working with a large consumer electronics company, and they have like 20 different product lines, and the data in each one of them is separate. But what they really want to do is create brand loyalty and cross-selling and upselling and help people through the life of their career to be loyal to this product brand. So they realized they needed to bring the data together into a data lake architecture that made it accessible to the enterprise. So they began to explore personalization and to understand their customers better through every aspect, every touch point they have with the customer and the external data that you can buy and bring in. So they're taking a very modern approach to creating a data foundation to feed the data scientist, to enable better decisions that up until a few years ago, it was perfectly acceptable to have a bunch of different data warehouses run by different groups. And that is no longer the norm. And chief data officers are changing that.
Maybe actually a great analogy to what you said would be what AMD and Apple have done with compute, every organization needs to do with data, right? Like if Apple is making your watch, phone, Mac, iPad, pretty much everything you use from a compute perspective, your smart speaker, your TV, they can integrate it all really, really well to the point where even the services, Apple Music, Arcade, TV, etc., you're going to use them all. If AMD is making the CPU and the GPU and they're working with the motherboard manufacturers, they can make it so they can have infinity cache so you can transfer data from CPU to GPU really, really quickly. So even if their individual CPUs aren't as good in single-threaded core performance as Intel, and their GPUs aren't as good as NVIDIA's in raw performance, together they perform better than NVIDIA and Intel CPUs and GPUs would work regardless. So kind of like
it's about the integration.
Yeah.
It's about the integration.
Yeah.
The other thing that's happening is, one, it's about the integration of data at the enterprise level, not the sub pieces, but the enterprise level. But then it's also the integration of data across an ecosystem. And so you're seeing companies emerge that are enabling data sharing, not just to the enterprise, but from the enterprise to the suppliers, enterprise to partners, enterprise to customers. Ecosystems kind of emerging as well. The value of data and the insights from data is growing. And I think people who really get that realize that their companies are shifting from product, which they may still sell, but to software and insights as well.
Absolutely. It's all about being able to remove those silos so we can integrate different data across different organizations, across different subgroups within organizations, and be able to find find insight within that large pool of data that we have now.
Yeah.
All right, let's see here. There is a little bit more of a technical question from Tanmay. He's asking, I have a question. If we create a fake face detector, for example, detect the output from a face generative adversarial network, would it consider real faces as fake faces? Will the model get overfitted? I feel like that's a bit more technical and down in the weeds of actually, training models. So I will definitely cover that really quickly, just as a quick note. It comes back to what Bret and I were talking about, that there's always some kind of imprint that machine learning models leave on data that they generate, and so do we as humans. And by being able to detect that imprint, you can actually figure out if a face, for example, is real or fake, right? If you go to thispersondoesnotexist.com, the face is absolutely great, the background is distorted, people beside them are always distorted, the ears sometimes kind of just blend into the hair, strands of hair just appear out of nowhere. So if you look for these patterns, you'll identify them.
But I have seen artificially generated faces that are no basis on any human, just generated, and they're amazing, and at a level of resolution you and I would never detect. So you have to look for other patterns, and eventually you have to look outside of the data itself from the face, but look at where it picked up elements from other faces and other things. So you'll see it's derivative of other works or derivative of other things, and you got to find that too.
Yeah,
it's an interesting space, and I'm excited by it because I think the potential, for example, to generate images of us forever. Tanmay, you may look like this forever because this might be the image that can be generated 1,000 years from now and it'd be undetectable as real or not. That's really cool. But we should at least understand if it's real or not.
Absolutely. It's something that's important to be able to detect if it's fake or real. And, with machine learning, we can help to identify those more low-level patterns that we as humans have a little bit of a harder time dealing with. So it is possible, I'm sure. It might not be easy, but it's possible. Right, because there is a pattern. Also, one of my favorite questions from NANO on YouTube. They're asking, do you think GPT-3 can reason? Really quickly, what I would say is GPT-3 looks like it can reason because it's been trained on an enormous set of data for an exceptionally long period of time on a lot of compute to be really good at predicting the next word, but it cannot reason in the sense that it was only ever trained on language and autoregressive language sampling. You ask it what color is a sheep, it'll say black because, it's only ever seen the phrase black sheep before, right? So There's fundamental reasoning and logical common sense capabilities that GPT-3 or really any language model lacks. But go ahead, Bret, what do you say?
Yeah, the answer, I would say no. I think it represents and mimics the behaviors and patterns that we've trained it on. And, but, I have friends who do the same thing. They sound smart, but when you really push them on a question, they don't actually know the next level. They don't have an original thought. They have a representation of what they've heard a million times from other people. Parrots sound smart. Parrots are not smart. They might answer every question correctly, and I think the idea of the Turing test got people thinking that if you could just ask questions and get intelligible answers indistinguishable from a person, that makes it intelligent. But intelligence is much deeper than that, and you know it when you talk to people. You know it as you sort of talk and you get into that conversation and you realize, oh my God, they know some stuff. They have some ideas, some points of view. They have a perspective, and they're also self-aware. I don't mean it in the robot sense. I just mean they're aware enough to know that they're aware. Like it's a very subtle thing. But other people are literally just parroting things. And GPT-3 is amazing. And the fact that it can generate text that sounds human is amazing. Just like the deepfake can generate an image of a person, it didn't know it was creating a person. It doesn't know what it's doing. It's just doing what it was trying to do. That is a distinction that I think people are seeing too much into it.
If I actually could maybe give it a little bit of an extension, right? There are two things here. One is to start off with like visual data. We've had software to deal with images for a long time now, right? Like we've had things like Photoshop that help us edit photos. And so we've almost gotten accustomed to the idea that machines can deal with images. And so when we see algorithms like deepfakes, we're like, sure, but yeah, we can deal with images, so we're not going to start saying, hey, this machine can reason now. But then when we start to deal with language, this is a brand new sort of unexplored territory for the vast majority of people not doing machine learning work, right? People that just sort of see the technology, they're like, wow, machines can write now, and subconsciously their brain is going, hey, any, thing that can speak in language happens to be human based off of my millions of years of evolution, and suddenly we're associating that with intelligence even though there is none, right? It goes back to one of my favorite examples ever, of a horse that could do basic arithmetic, by actually tapping its hooves on the ground. But it wasn't actually doing arithmetic. Like, you'd say 2 plus 2 and it would tap it 4 times, but it would just stop when everyone looked happy and they were like, oh, you got 4. So,
I love that example.
Yeah, I know, it's great, and it sort of just shows that GPT-3 is not learning anything. It doesn't understand. It's not an intelligent thing. It doesn't even make sense to say that GPT-3 doesn't understand anything, because that's not a thing it can do, right?
Right.
But
I do understand how people. I do get how people want it to.
Yes.
Right. And it's no different than if you played with a Sony Aibo, robot dog. It's so cute. You want it to be aware, and it may recognize you versus me, and you think, oh my God, it knows me. But it doesn't know you. It just knows your face matched a pattern. And when you raise children, you sort of notice these moments where they do what you train them, and then they do something you never trained them on, and you suddenly realize, oh my God, they're extrapolating, they're learning, they're thinking, they're creating. It's a great moment, and I don't know if there'll be a moment where AI does that in my lifetime, but I think we're overthinking it too much by worrying about it now, because the limitations are so extreme. There's so many limitations. We should focus on what it does well, and leverage it for that, and just make it do those things better.
I completely agree. And I mean, also, just really quickly, we don't need to dive too deeply into this, but Nano is sort of expanding upon this, and he's saying that's a super philosophical question. I still believe in determinism and think that our brains are like GPT-3. We just reproduce what we're thought, illusion of choice, and maybe consciousness is just a byproduct of how the brain works. I gotta say, personally, again, this is not something that we can objectively answer right now. Personally, I half agree, half kind of disagree, in the sense that I agree that, even as humans, I believe that choice is pretty much just an illusion that we have, right? Our brains fundamentally do kind of work like GPT-3, in the sense that we are just reproducing what we were taught, and that this is just a byproduct of the way that our brains do this sort of mimicry, just at a much larger scale, in a completely different way than something like GPT-3. I do not think that GPT-3 does what it was taught in the same way that our brains do it, because GPT-3 was only taught to generate the next word in a sentence. Our brains are taught to survive and have evolved to do so over millions of years, and doing so has required different abilities like general purpose natural language understanding, and being able to encode thoughts into language and decode them if you're hearing language, and being able to identify visual objects and all these things. There's been a completely different objective for training the brain. There's been a completely different method of doing inference against it, a method that we still don't completely understand, and it's arguable whether or not we completely ever will. So it's an interesting discussion, but a long one.
Yeah, an AI might have completely predicted you would say every word you just said.
Yeah, absolutely.
It doesn't mean it understood what you understand.
Completely.
I think when I think about this a lot, and most AI is what we call narrow AI. It does a specific thing. And that natural language generation is a very specific thing. It has none of the other framework that makes us who we are. We are not just one AI. We're thousands of AIs that evolved over a very long period of time in our brain, that are all working at the same time. There's something in there creating. There's something in there dreaming. Each of those things is all working holistically to keep us alive so we don't die. Whereas GPT-3 is only predicting the next words or phrases. And I think once you recognize it's doing a narrow thing, it's not that it's not smart. It's just that it's only doing one thing. We do so many more things all the time, constantly. And, if we ever combined all the AIs of the world and had ones that simulated all the things that we do in our brain, if we ever understood that well enough, maybe it would appear more like us. But I think we're thinking way too far ahead.
Absolutely. And just really quickly, one more thing that I think is really important to think about, right, is that as humans, the way that we came to this sort of evolutionary moment where we invented language, first of all, was a great coincidence. But the reason for it was pretty simple, is because as humans individually, we're weak, we cannot survive in the wild. But put together 10 humans, and suddenly we're some of the best, animals in the wild. But we only are that way if we can actually work together. How can we work together? If we can communicate with each other really advanced and complicated concepts and imaginative thoughts and things that might happen in the future but might not, and so evolution was kind of like, language is a great way to do that. And so we have this ability of not just taking phrases and predicting the next word, but taking any random arbitrary mental state and being able to encode that to language and sort of get that across either through writing or through speech in a way that other humans can hopefully decode that into a very similar mental state. But then, we take a look at GPT-3. That's not what it's doing at all. It wasn't trained to communicate in any way. It was only ever trained to predict the next word in the linguistic data distribution. So it's interesting to see.
I don't think that's meant to. I don't think that diminishes what it does, nor any of the other AI systems. I think it's just recognizing the narrow but really powerful thing that it does. What I'm very excited about is when you look at AI and its usefulness today in business, those narrow use cases are very powerful in and of themselves. I can read 4 contracts in an hour. Maybe I could read 40 in a day, but an AI-based system could read 4,000 in a minute. And so if I wanted a system that would help me process contracts, I should feed them all in, and it should tell me, you have a problem in this contract, you have a risk here, you have a compliance issue here. Don't make me read the whole thing anymore. I can actually use AI to do my job better, which is decide how to deal with the problems. I could look at the data streaming off a device all the time, but an AI could tell me in 3 hours, this is probably going to fail because this part seems to be wearing. And it will know that from the data, and I don't have to watch all the time. So I get a 3-hour warning, I turn it off, fix the part, keep going, and minimize downtime. Once you recognize the strengths of it and use it properly, a lot of these discussions are fun, but they're not an inhibitor to using AI every day to do really powerful things in business or in life. And for those of us who are practitioners, we can solve really great problems using all the data that exists in the world and these kind of very narrow but powerful use cases to scale what we do. Absolutely. And I think that's what's exciting about it, is the potential to scale our own human capability with systems that can read and see and generate text on our behalf.
Totally, absolutely. No, I first of all completely agree with you, right? My idea is not to say that these systems aren't useful because of the fact that they're so narrow, but rather that we are trying to apply them or we're thinking about them the wrong way. If you judge a fish by its ability to climb a tree, obviously it's going to live its whole life thinking it's dumb, right? Famous quote, right? If we judge GPT-3 by its ability to be human and reason and generate text, as it just like a human would and write a novel like a human would, then obviously we're going to think GPT-3 is absolutely useless. But then when we actually start to judge GPT-3 by what it is good at and not just what the media will hype, like for example, actual content search or summarization and things like this, then we start to see the value in these techniques. So I feel like that is definitely an interesting area to look into. How can we apply those narrow sort of AI tasks or systems to actually add value is the whole goal.
Yeah. There's a developer who's using GPT-3. He built an app that trains it on everything he types and texts and emails and all that stuff to basically generate a bot of himself. So you could create a Tanmay bot. You feed it all the text that you would say, and it will answer predictably as you might. And it might even sound like you most of the time. But it wouldn't be able to conduct this interview.
Yeah.
Because we went way off normal topics into areas that just caused us to each think and create and extrapolate. These are not things you would have done in an AI system today.
Absolutely. There are brand new thoughts that I've thought today that I would have never thought before, right? And it would have been impossible for GPT-3 to predict what I would have thought based off of that previous data distribution. And so we really got to start thinking as to how can we actually focus on adding that value with these narrow AIs. And Anna was also talking about how there needs to be more research on connecting several different AI systems for more complex tasks. People have been working on it. Microsoft has their brand new image captioning bot. Apple Face ID isn't just one network. It's actually like 4 different neural networks all working together to figure out who you are instantaneously on an iPhone or iPad, right? So there is work being done here, just not towards that whole general intelligence thing. As one of my great mentors, Rob High, says, and I love this quote from him, is that, in theory, maybe in the far future, it would be possible for us to say, all right, we can build a human brain within a computer, but then why would you want to just replicate the same limitations of a human in a computer? The whole point of using a computer is to make it so we don't have those same drawbacks. So why would you just want to simulate the same limitations in a computer again? We already have 8 billion human brains. We don't need more of them. We need more computers and what computers are good at.
Yeah.
So... I feel like it's all about that value at the end of the day. But those. Oh, also one more question from Rashu. He's asking, will convolutional again a little bit deeper in the technical weeds here, but will convolutional neural networks be replaced with encoder decoder architectures in the future? Totally. I wouldn't say encoder decoder. I think you mean transformer architectures. The new image transformer work done by a couple of researchers, forgetting their names unfortunately, has caused a lot of hype in the community, I will say. People are like, oh, transformers are replacing convolutional networks too now. And it's interesting work, and I can see why a few different convolutional neural networks might easily be replaced with transformers, but if I do remember correctly, it still requires an immense amount of computational power, and there's still some drawbacks to it. So I can see slowly transformers getting more advanced and sort of doing more things, but just the fact that their attention layers they have like, n squared, like space complexity and stuff, it's too computationally intensive, I think, right now for any real tasks. But they're working on it. There have been teams that have made these a lot less computationally expensive, but I'll cover that more in the actual deep learning series. For now, though, anything to add to that, Bret?
No, nothing to add. I can't wait to see that series.
Thank you. It's I gotta say, it's a really fun series to work on. But those were the questions from the live stream. I mean, I gotta say, I've learned a lot about the world of machine learning from a completely different perspective than I usually look at it today. And as a matter of fact, Bret, one more thing that I want to ask you is, I mean, as I mentioned on TechLifeSkills, right, there's a really diverse range of guests that come on the show, but also a diverse range of people that come on, some being more developer focused, some people being more business focused, and students and all these sorts of people. And if you had to get across a message about the world of AI and machine learning to all these all the guests on the show today, what would that message be?
There's no question that the world is becoming more data-driven, and that there's more data now than there's ever been in all of history. In the last couple of years, I think more data was generated than in all of history. I've looked at the publicly available data sets outside of an individual company. 2 years ago, there were 33,000. Now there's 200,000. It's growing every day. I think if I could suggest anything, it's that becoming more data-driven, unlocking the potential value of data, seeing across the boundaries of data within your company, across the world, and seeing the possibilities and meaning in that data is a highly competitive advantage. And those of us who spend our time working with data, thinking about algorithms, seeing and unlocking that potential are going to change the world. So I would encourage people to really embrace this data level thinking, knowing that most data is not meaningful. Finding meaning in data is actually the power, and finding new meaning that no one else has found is the competitive advantage. So I'm very excited about the potential. I hope your audience and other people are helping to do this, because they're going to change the world. We can see this already with the pandemic and people using data to help fight the pandemic. I think this changes the world in so many ways: the environment, society as a whole.
Thank you very much. I mean, again, that's really my goal through my whole YouTube channel, right, including this series, is to empower people with that knowledge of technology and even more around it, so that they can change the world. And you're right, I think, when you're aware of this technology, even if it's not from a technical perspective, no matter what role you're in, it could be a leadership role, could be a technical role, whatever it is, as long as you have this awareness of this technology, you can make an impact. You can apply it where it makes a difference. And what we've talked about today around these different misconceptions that people have, literally people signing, expensive contracts when it comes to AI, asking what's going to happen when it thinks it no longer needs us, right? Being able to understand this technology is absolutely critical in understanding where you want to apply it, why you would want to apply it, how to structure your organization to best apply it to have that competitive advantage. So thank you very much for your thoughts, Bret. I really appreciate it. This has been a wonderful learning experience for me, and I'm sure a wonderful learning experience for everyone on the show as well.
Thank you so much, Tanmay. I love the questions from the audience. It was fantastic. So thank you very much for having me.
Thank you very much, Bret. It was great having you on the show, and I also want to say a huge thank you to everybody joining in today on the live stream. Thank you for being a part. Of course, the series is held every Sunday in the morning Eastern Time. If there are any questions we didn't get to, put it in the comments. We'll get back to them very soon, and make sure you join us next week, where we're going to be talking well, I can't say just yet, but make sure you join us next week. You're going to be hearing more about that episode later this week. So thank you very much, everyone, for joining today. Thank you very much, Bret. Really appreciated having you on the show. It was an honor, and I'll see you all next week. Bye-bye.
Thank you.